Horizon just almost reaction. This is the insane engineering of M1 Abrams. Yes, the infamous, not in, why did I say infamous? Yeah, the famous tank. Yeah, infamous to Russians, I guess. I don't know. Yeah, the one of the famous tank. I'm guessing the most powerful tank. The last generation. I don't know. I'm guessing the newer equipments are coming a lot, like F-35s. Apparently T-14, which is like whatever kings it might have, once it's like they iron that out and does actually mass produce, it would be like insane thing. I heard that there's also Abram X apparently, which is like next generation of this American side, which is going to be, I'm guessing it's going to be more insane. So this is like the, so far up until now, the most powerful tank there is, right? M1 Abrams. It's American, right? Is it British? I'm pretty sure it's American. I don't know. I need to Google that. Yep, it's American, obviously. Made by Chrysler Defense. Chrysler makes defense weapons, tanks and shit. That's first, okay. Chrysler basically owns Ferrari and everything. So yeah, in automotive, Chrysler is a big thing. But I didn't know about the defense. Okay, this reminds me of the Samsung, right? If any of you watching don't know what the fuck is Samsung, like the scale of it, seriously research it, right? I don't know if somebody made a video about that or not, but Samsung is fucking insane. There's nothing at a large scale you can think of that Samsung doesn't do. Samsung has its own fucking army and military, like tanks and shit and everything. They have their own city. They make like freight ships and things, like one of the largest freight ships you can think of. Basically, economy is based on that freight ships, right? They make basically RAM and everything, LED screens and whatever on mobile and thing. Apple phones have Samsung screens in it. Like, I can make the fucking list. They even make cars for Koreans. It's only in South Korea for some reason. I don't know why. Just like if you're gonna make it, might as well make it for the world. I don't know. It's like obviously all the home appliances, everything A to Z. I don't know. It just remind me of it. So yeah. So insane engineering of M1 Abrams. I'm guessing this is just gonna be like old style analog, not analog, but not electric, right? Manually inserted thing and everything, but just gonna be powerful, full, just blank. Yeah, let's watch it. Remember, if you like my reaction, don't forget to subscribe. That way you can help this channel by helping the algorithm. People can get more impressions, which is basically talk for more people can see this video recommended to them. And yeah, comment down if you want to do any other reaction. This is the thing I started doing recently. As soon as I start watching Federation video, this like rabbit hole open for me. All military things. So let's watch it.
The M1 Abrams entered service in 1980, a fast, heavily armoured tank with the very latest technologies to give it every advantage on the battlefield. First seen action in Operation Desert Storm, the plain, arid camouflage tank gained a reputation quickly in the barren deserts of Saudi Arabia and Kuwait. Powered by a high-speed turbine engine, the M1 raced across this difficult terrain to liberate Kuwait from Iraqi occupation. The German-designed 120mm smoothbore cannon had longer range, more accurate fire, and more advanced ammunition. It easily dispatched the lower-tech Soviet-supplied tanks of the Iraqi army. Sometime this year, it's expected that the US will deliver a battalion of 31 M1 Abrams tanks to Ukraine to once again face off against the Soviet tanks.
Is 31 a lot? I mean, don't Russia have like thousands of them? I don't know how many, I don't know what is the situation there, but I'm pretty sure like before the war started, I remember seeing the stat of like Russia has something like, I don't know, thousands of tanks with them. Is 31 a lot? I don't know.
Was designed to battle. The Ukrainian army will need training to maintain and operate these new tanks because they are like no other tank. And although this tank is over 40 years old, it's still more than capable of holding its own on the battlefield, thanks to continual modernization and forward-thinking design.
I don't know why I'm surprised. He said Desert Storm. So yeah, of course 40 years old makes sense, right? Desert Storm was what, 30 plus years ago?
This is the insane engineering of the M1 Abrams. The M1 Abrams, upon engine startup, sounds more like a military aircraft getting ready to take off.
Really? What the fuck? Really?
a terrifying increasing pitch as the engine revs up to speed.
Is it a supercharger? What
The
is it?
whirring sound emanating from the rotating turbine blades hidden inside. The turbine engine, typically used for jet aircraft, is an engine designed for high-speed operation with minimal weight, a counterintuitive choice for a heavy battle tank. So why was it chosen? The turbine engine would give the M1 two huge advantages. They are much lighter than an equivalent diesel.
Yeah, I'm not gonna lie. As soon as it's a turbine engine, I'm like, yeah, that's the shit. I don't care anything. Is it better? Is it not? I don't care. It's turbine engine. Let's go.
Weighing just 1.1 tons and developing 1,500 brake horsepower. The V12 diesel engine of the Challenger 2 produces 1,200 brake horsepower with 2 tons of metal.
I don't get that. Like, why? Why give a tank a V12 engine? Like, you can give V18 engine. Why not W18 too? Tanks don't. I don't know. I get it. Like, tanks might also need other things as well. But it's a fucking tank. Make it a bigger one. I don't know. How big a tank is gonna be if you have to put a bit bigger engine in it? Like, it's not like the fuel to weight ratio that is in rocket type of thing, right? If you put something like 20 cylinder, 30 cylinder massive engine if you need to, how much weight is they're gonna increase compared to the horsepower they would deliver, right? I don't know. Maybe I'm just like talking stupid, but yeah, I know. I'm pretty sure even Rolls-Royce BMW created for Rolls-Royce a V18 engine, if I remember correctly. What? V18? Yeah, V18 engine or something, which was insane. So something like that.
Compactness and extreme high power to weight ratio allows the M1 to stack on layers of armor without sacrificing acceleration or top speed. We can plot torque versus shaft speed of the Honeywell AGT 1500 turbine engine of the M1 against the V12 MTU 883 of the Challenger 2E, and we can see the turbine has a massive torque advantage at lower shaft speeds.
Oh, I didn't see that figure. Oh, it's a torque. Newton meters, 7,000 Newton meters. Okay. Oh, I'm not gonna lie, that torque would come in play. For a actual battle vehicle, torque is important. Torque is literally the muscle of the vehicle. Horsepower just implies like how fast you can go. Torque, obviously torque is the one that gives you horsepower figure. But torque basically is like brute force. Like if you have a torquey thing that can just pull out shit, right? So this engine has this kind of a torque at the, it can basically just tie up things and rip out walls if it needs to.
The turbine has a massive torque advantage at lower shaft speeds. In its lightest configuration, the M1 weighs 61.8 tons. A typical Toyota Corolla weighs 1.1 ton. That's
Really?
equivalent to 56 Toyota Corollas.
Did they just pull off real life lore
can
thing?
accelerate from 0 to 32 kilometers per hour in just 7 seconds with a top speed of 72 kilometers per hour. The M1 Abrams primarily uses diesel fuel, as diesel can act as an additional layer of armor. Liquids are extremely good at absorbing energy from explosions and kinetic energy weapons. They are most effective against shaped charges, and tanks carry a lot of liquid in the form of fuel. It may seem counterintuitive to use fuel as protection from an explosion, but diesel fuel is not very flammable. In fact, if you throw a lit match into a puddle of diesel, it will put the match out. Diesel engines require immense pressure and a sustained flame to ignite. Because of this, diesel can be used with relative safety as armor. However, the turbine engine can...
Because of the pressure, usually diesel engines have a really strong torque to it. This is why when petrol turbo thing wasn't a big thing, diesel turbo cars were like the shit. I still remember I think it was a Lassetti I had. You call it Lassetti in America. In here it was called Optra, but it was like a 2-liter turbo diesel engine with Bosch part to it, German Bosch. It was an insane car.
Can also operate on most fuel types. This is a huge advantage in military logistics, making joint operations with NATO vastly easier. In the years following World War II, the Soviets favored diesel compression ignition engines. The Western Allies used a mixture of both gasoline spark ignition and diesel compression ignition. Transporting fuel is one of the largest logistic challenges in war. Needing several types of fuel makes it all the more difficult. The M1 can run on marine diesel M1 can run on marine diesel, gasoline, or even kerosene if needed, which not only makes it easier to procure fuel in a war zone, but comes with the added bonus of helping the M1 operate in hot or cold weather, dealing with the wild swings in temperature that Ukraine can expect throughout the year with ease. Where diesel fuels can crystallize at low temperatures, kerosene can be used instead. The turbine engine of the M1 works similarly to aircraft engines, with some important differences. Air enters the engine here, where it is compressed by the low-pressure compressor, and then the high-pressure compressor, each individually driven by separate turbine stages. These turbine stages are driven by the combustor, which works a little differently to typical aircraft combustors. It is mounted perpendicularly to the engine and protrudes out of the engine. This makes maintenance access to the combustor easier, with only a simple bolted cover needed to be removed. There are two drive shafts in this engine. A secondary drive shaft driven by the high-pressure turbine, which runs forward to an accessory gearbox that runs things like compressors, electronics, and hydraulics. The main drive shaft, driven by a dedicated power turbine, which is not connected to the compressors, runs rearward to the tank's drive sprockets. This primary drive shaft and its reduction gearbox is surrounded by something called a recuperator. This is the biggest difference between this turbine engine and a typical aircraft jet engine. We don't want the hot exhaust of this engine spewing out like a jet engine. The heat signature this would create would be a giant beacon for heat-guided missiles and give the tank's location away to any enemy using thermal vision. We also don't want to waste all that heat energy. The recuperator is essentially a giant heat exchanger. Air coming from the compressor stage is passed through it, where it is heated by the exhaust before entering the combustion chamber. This lowers the heat signature of the exhaust and increases fuel efficiency, transferring more heat energy back into the engine instead of losing it to the atmosphere. But the M1 Abrams is still a thirsty machine, even by tank standards. The turbine engine uses twice the fuel as a comparable diesel engine per kilometer, where the M1A1 consumes around 4.2 litres per kilometer. While cruising at 40 kilometers per hour, the Leopard 2 consumes 2.2 litres per kilometer. But the US military deemed...
Look, fuel is a factor when it comes to war, so isn't this a big issue? Like, what the fuck?
This issue a cost worth paying for the capabilities the turbine engine provided, allowing the M1
now, but if shit goes down, this will be a problem.
to carry an obscene amount of armor while keeping its acceleration high. The armor installed on the M1 Abrams has evolved and changed over the past 4 decades. The exact details of its thickness, location, materials...
Yeah, so basically they gave it low and high torque. That's why this engine was put, even though it consumes twice as... I can see that, like, it makes it easier to maneuver, right, with this kind of a heavy-ass tank. And it is like a good trade-off, like you said. But yeah, I think like the biggest issue Hitler came across was the fuel, right? The resources. Like, I guess like they're thinking if that type of war does come out, tank is not going to be a deciding factor, I guess. Like everything goes to shit. World War III is just going to be fucked up all around. So at this point, like, why does it matter? So I guess this tank was made for like your, some battle here and there, some war here and there, rather than a big-ass war, maybe.
And layering is classified for obvious reasons, but there is a great deal known about the science and nature of its armor. It is well publicized that early M1 variants used a type of composite ceramic armor called CHOPM, which derives much of its ballistic resistance from an extremely hard and light ceramic layer. Hardness in material science is a measure of a material's ability to resist localized deformation, like a scratch. Diamonds are extremely hard, and because of this, industrial diamonds are coated onto cutting tools to help them cut through materials without being eroded themselves. A hard material can scratch and erode a softer material. Hardness can be measured with a Vickers hardness test, which pushes a pyramid-shaped diamond into the material. The hardness is then calculated by dividing the force applied by the resulting surface area of the indentation. The rolled homogeneous armor steel of World War II has a Vickers hardness test of 380. A high-carbon steel is about 550, while a ceramic like silicon carbide offers a hardness 5 times greater up to 2,500, while being much lighter than steel, making it an excellent candidate for armor. But anyone that has dropped a dinner plate knows that ceramics are extremely brittle. They shatter into a million pieces with little force. But this can be used to the tank's advantage when combined with a tougher metal backing plate. In this configuration, the ceramic is placed on the outside of the metal plating, acting like an extremely hard outer shell. When a round strikes the armor, the compressive strength and hardness of the ceramic coating causes the round to fracture and break apart. At the same time, the ceramic coating begins to fracture and fragment, spreading the energy of impact across a larger area, which is then absorbed by the tougher metal plate backing the ceramic. Tough in materials.
That is good. Like ceramic is brittle like that, but that is like good element to it. That's the energy. Basically, when you really learn physics, you realize like everything is basically energy and energy transfer. So if it like breaks like that, it just like absorb a lot of energy to it. That's why it breaks like that, right? And then the back plate, whatever remains, it back plate can basically spread it out, which is kind of like good. But isn't like okay, there's like one and done type of thing, isn't it? Like okay, one ceramic like that's a hole there. Next time it get attacked, won't that be an issue? But I guess like that's the whole thing of tank. Like it's not supposed to like take a multiple damage like that. Like few damage here and there, job's done, go back to repairing, I guess.
Science means it can absorb a lot of energy without fracturing, the opposite of brittle. Further research and experimentation found ceramic armor performed even better when placed under compression. This can be achieved by simply adding a faceplate and bolting the two pieces together. This changes the dynamics of an impact significantly and helps immensely with resisting attack from long-rod kinetic energy projectiles. These are rounds specifically designed as anti-armor weapons. They are thin, long, dart-like projectiles that require a sabot to launch out of tank barrels. They are typically manufactured from high-density materials like tungsten, with a thin aerodynamic shape and high density. These weapons have an extremely high ballistic coefficient, allowing them to ram into targets at a distance at high velocities. They can obliterate rows of concrete walls with ease. Embedded compressed ceramic armor can defeat these kinetic energy weapons. When the long rod projectile strikes the faceplate, it sends a pressure wave through the ceramic that pulverizes it and increases its volume. This creates what is essentially an abrasive maze of extremely hard and sharp particles the penetrator has to push through, gradually grinding it away. Computer simulations of this effect show that the harder the material, the better. This is the magic of ceramic composite armor. On top of these metal and ceramic layers, there is typically a very dense inner liner called a spall lining. Projectiles don't necessarily need to penetrate every layer of armor to be deadly. If they hit with enough force, the kinetic energy can simply transfer through the material as a wave and cause material on the inside of the tank to splinter and turn into deadly shrapnel inside the crew compartment. This is called spall. Some munitions are specifically designed to cause this. High explosive squash heads are made from soft plastic explosives that spread out over the armor surface.
It's basically energy transfer, all this ballistic projectiles, right? Finding just the right way to basically transfer energy like that is like really like all the ingenuity just to kill each other is just awesome. But it's like science is awesome basically. So you can have all this, but different type of ammo basically. If the job is done, if it's like transferred inside, like there you go. That's just fucked up. I still remember like one of those videos. I don't know which video was that. Who talked like being inside a tank is just horrendous. Like if a projectile basically hits you, it's gonna be in pieces, and if it hits inside of you, it will be all over the place. Gonna get hit by all sides, and you're basically trapped in a small area. So imagine like enlisting in army, getting a post of basically being in tank, and you have like that kind of like what that phobia, right? Close space phobia. That would be insane. I'm guessing that military would realize all these things like, okay, you have the phobia, so they would basically transfer you somewhere else. But if a war breaks out, they just basically tell you tough shit out. I don't know. That would be insane.
Increased surface area and direct contact with the armor, the explosion transfers a great deal of energy through the material and blows out the armor's backing. This works by sending a compressive shockwave through the material and reflects and rebounds inside the material, creating regions of intense stress that fractures the armor. The spall liner is a ductile and dense material that limits spalling. For early M1s, this layer was typically composed of lead, but beginning in 1988, certain M1A1s began to be upgraded with depleted uranium spall liners, which are even denser than lead, and all new M1A2s were assembled with depleted uranium liners. However, modern composite armor makes it difficult for the shockwave to transmit through the material, and a spaced layer with an air gap can defeat this squash head munition completely. Additional reactive armor tiles can be added to the outside of the M12. Reactive armor is particularly effective at dealing with shaped charges. Shaped charges consist of a charge shaped with a hollow indentation lined with a ductile metal liner. When the charge is detonated, a pressure wave forms behind the metal liner, deforming it and accelerating the metal into a lance-like stream of particles. The shaped charge effectively creates a hypersonic projectile at point-blank range. It's highly effective at cutting through armor. Reactive armor works by placing an explosive charge between two metal plates. When a jet from a shaped charge strikes the upper plate, it detonates the inner explosive.
That is
You may think this
insane,
could
man. So they figured out a way to actually launch a projectile, and when it hits the projectile, there's another projectile inside that will go like even insane speed and just pierce through. So basically, no energy wasted trying to travel because the main projectile will shoot at the end.
damage the tank, but the tank's lower armor is more than capable of dealing with the relatively blunt pressure formed by the reactive armor detonation. The outer plate then flies outwards to disrupt the incoming jet, while the shockwave formed by the detonation also breaks up the stream of metal approaching the tank.
Whoa.
Of course, the best defense is to not be hit at all, and the M1 can create a smokescreen for itself when needed. The M1 has two systems for generating smoke to conceal itself in an engagement. The first involves simply spraying fuel into the engine exhaust, which vaporizes the fuel and creates a large opaque cloud behind the tank. However, it's extremely important that the driver remembers which fuel the tank is running on. This works for diesel fuel, but if gasoline or kerosene is used, it won't conceal the M1, it will set it on fire. The second system uses grenade launchers.
Oh, I'm not so sure about that. Okay, if you're gonna create any system, there's like a user can fuck it up, and one is an advantage, other one is actually fucking your tank up. That's a problematic, right? I mean, obviously, military is not commercial. People, average people, fuck shit up in real life. Okay, that makes sense, but soldier wouldn't do that. Like that's their whole thing. Their lives are depend on it. Don't fuck up that like. Oh, by the way, did you put diesel in? No, it was kerosene. You mother, that's not gonna happen. By the way, our ass is on fire now because I thought there was diesel in it. But still, like that's like okay.
Mounted on the outside
What
of
if
the turret.
it fail does
there
happen?
Are two versions the M1 uses. The 8-canister M257, typically used with the US Marine Corps M1s, and the more widely used 6-can M250. These launchers are controlled from the tank commander's seat here. Pressing one button launches 6 grenades, 3 from the left and 3 from the right. Pressing both buttons launches all 12 of the grenades, launching them about 30 meters from the tank and providing a shrouding curtain of smoke to hide its movements.
But how is that gonna hide thermal? Like most of the anti-tank thing uses thermal. Imagine like smoke cannot stop that.
Engineers of the M1 Abrams did everything in their power to make the M1 as survivable as possible, protecting the crew inside. And the highly trained crew are the most important part of this machine. The M1 Abrams does not have an automatic loader like many modern tanks. It has a dedicated crew member, the loader, to load rounds into the breech. Auto-loaders are a feature of modern Russian tanks. However, the USA have shunned them in their tanks, seeing an auto-loader as an unnecessarily complex mechanism that would impact the M1's reliability. Seeing
Not
a
a
fourth
bad
crew
point,
member
actually, not
capable
gonna lie.
of keeping watch, maintaining
I get it, like T14 has that, and I don't know, like you know, you could argue that with anything. Like, isn't that better just like having old tech? But you can't stop the newer technology. So auto loader will be a thing. But I feel like that would be a thing mostly if you want to make it like an RC type of thing, right? Like no man inside, mostly remote control tank type of way, or AI powered tank. I still remember there was like a Top Gear video from 15 years, 15 or more than 15, something like 15 years ago. where they used an American truck or something that was just like mostly was not uh, AI. I don't was it AI part? But yeah, basically there was no man inside. It was just scanning the road and just going basically to make sure that nobody gets hurt trying to transport something in the battlefield. That was 15 years ago. So unmanned thing are being a thing of the future. Like if you're gonna have equipment and now AI is a thing, computers are so complex. Why the fuck have a man inside? So by that point, like you will need an autoloader. And if you're gonna shun the autoloader now, like one thing is for technology, you have to have technology whether you want it or not, just so you can improve on it, right? That's the one thing we learned in any technological areas, especially smartphones. So if T14 has like a autoloader, then they get it better and better. And if Americans basically shun it, when it times to have an autoloader, they'll be the new to it. And the Russians are probably going to be already experiencing this, right? So they'll be lagging behind in that way. So I don't know. Even if they don't want to use it on tank, they should still like experiment with it just to keep up, right? Just to trial and error, because that's going to be a thing in the future.
The vehicle and taking over responsibilities in an emergency as an advantage, not a disadvantage. The loader enters the tank through the turret hatch, sitting to the left of the main gun with access to the ammunition box behind them. The gunner to their right is in charge of aiming at targets using these day and thermal night vision sights, along with a laser range finder to input target distances into the ballistic computer. When instructed by the tank commander sitting behind the gunner, the loader will press a switch with their
Why are
knee
they inside
to open
white?
a hydraulically actuated armored door behind them.
So it looks
The tank
everything
commander will
looks.
specify the round needed.
Is this because even with a bit of light, everything is illuminated? That's why everything's white inside.
And the loader will take it out, load it into the breech, close the breech, and move the safe handle into the armed position. This process will be repeated until a ceasefire is called by the tank commander. The armoured ammunition access door is only open when loading, and this is crucial for the survivability of the M1 Abrams. If a round penetrates the ammunition box, it can result in a lethal detonation of the ammunition stored inside. This armoured door is capable of withstanding this blast, and panels on top of the tank, called blowout panels, are designed to break and allow the pressure and heat to be directed upwards and away from the crew. These rounds are fired out of the M1's 120mm cannon. Early M1s were fitted with a 105mm cannon, 105 referring to the bore diameter of the gun. This decision was made primarily to allow a sharing of ammunition and parts between the 105mm on the previous generation M60 tank. With the development of depleted uranium rounds, it was viewed that this gun was more than adequate to deal with any Soviet armor. However, US allies like Germany did not want to use depleted uranium rounds due to ethical implications, and were moving towards 120mm cannons, with the British Chieftain tank using the Royal Ordnance L11 and the German Leopard 2 using the Rheinmetall RH-120. This posed a problem for NATO's goals of standardizing wherever possible to optimize logistics. With ammunition factories across NATO countries producing the same ammunition, this ensured ammunition could not only be shared, but manufactured as close to the front line as possible. The 120mm guns of the M1A1 and M1A2 are in fact German Rheinmetall RH-120s, manufactured under license in the US, a 5.3 meter long, 3.3 ton smoothbore cannon. This large bulge in the middle of the cannon is designed to evacuate the barrel of propellant gases after each firing. Once the round leaves the barrel, atmospheric pressure can prevent the gases from leaving, and once the breech is opened, the potentially harmful and explosive gas can enter the crew compartment. The bore evacuator is a pretty simple solution, with holes that allow gases to enter the evacuator as the round passes by. This acts like a pressure reservoir. When a round leaves the barrel with this attachment, the pressure is released from the forward-facing holes at the far end of the evacuator, and this pushes the remaining gases outwards. The two primary rounds used by the M1 are the M829 depleted uranium round, which is a sabot kinetic energy round, and the M830A1 heat round, which, despite its name, does not use heat as part of its offensive. It uses a kinetic energy shaped charge. We have been piling on weight in this vehicle. The armor, cannon, engine, and ammunition makes.
You're not gonna lie, the engineering is just fucking awesome. I mean, that's like expected. But yeah, I like how they thought of basically literally everything they can think of. Okay, basically they just probably sit around just like, let's think of all the things. Like probably ask some experienced soldier like, what is the problem you face, and just like start to tick boxes. Rather than usually when people think of like, okay, let's make sure like create a system where somebody shoots something, it can deflect. That's about it. But they're like all different type of ammos. Okay, we need to create an armor for that to counter all this. If they do this, we have to do this type of shit. Okay, what if the gas is getting, okay, let's create a bulge type of thing that would make sure the gas goes out and not inside.
Makes this an extremely heavy vehicle, weighing between 52 and 68 tons depending on the generation and configuration. The M1 Abrams needed a track and suspension system capable of bearing that weight. For a vehicle this heavy, typical helical springs have some problems. First, their maximum travel is limited. At a particular load, the layers of a helical spring will meet and no further travel is possible, bottoming out and providing an extremely uncomfortable ride for the crew. To deal with a heavier vehicle, we need to increase the spring coil diameter, taking up an increasing amount of space. This was an issue for World War II era tanks, with the M4 Sherman opting to use a volute spring, which is a conical spring that is capable of compressing to a much smaller size as the sheets of spring steel overlap. However, most modern tanks utilize the torsion spring, which take up very little space inside the tank, though they do raise the tank's height considerably. The torsion springs of the M1 are located here, and because they are inside the hull, they raise the hull height by 150 millimeters. The road wheel is attached to a lever which can travel up and down. This lever arm is attached to the torsion bar so that it twists when the lever arm moves up and down. The spring force is derived from the bar's resistance to torsion. Older tanks incorporating torsion bars had limited travel. The M1's predecessor, the M60, had a wheel travel of just 20 centimeters. During the development of the M1, the two tanks were pitted against each other. With the M1 benefiting from 20 years of material science progress, its max travel was nearly double that of the M60 at 38 centimeters. When tested on a track with a series of 30 centimeter bumps at 32 kilometers per hour, the M60 managed to break its front wheels, lost control, and broke the driver's arm. The torsion spring of the M1 runs along the width of the hull, making them quite heavy. We need the torsion spring to be as long as possible because the travel distance is a function of the torsion bar's length. Longer torsion bars can twist more before breaking. An interesting quirk of the torsion spring system is that typical designs, like the M1's, mean that the road wheels cannot be aligned. We cannot connect the lever arms of opposite road wheels to the same torsion spring, as they would frequently travel together, creating no torsion. The far end of the bar needs to be rigidly mounted to the body of the tank in order to develop a spring force. So, two torsion bars need to be mounted alongside each other, creating an offset in distance between the two sides of the tracks. The two sides.
I understand that, but I don't know. Doesn't it feel like more of a more simplistic answer? Don't we have better technology than this? It's like using torsion as a suspension. Okay, I guess it makes sense, it works, but I don't know, it feels like a very low-tech answer, isn't it? I don't know. There has to be a better answer than this.
Sides of the M1 are not symmetrical. This comes with some drawbacks. The leading road wheel will hit bumps first, meaning it will absorb more force than the trailing road wheel, increasing the wear on the leading torsion spring, resulting in more frequent replacements. Torsion bars are very easy to swap out when they aren't broken. But if bent or shattered, or if the body of the tank is bent, it can be difficult to pull the long torsion springs out. Modern tanks are increasingly moving towards hydro-gas suspensions, which look like this. The road wheel has an attached axle pivot arm, which in turn turns a crank and a conrod piston. This piston connects to a hydro-gas suspension cylinder. The first chamber is filled with a fluid, typically oil. The oil is relatively incompressible and so provides marginal spring force. But this chamber has a damper valve that serves to restrict the transfer of fluid between this chamber and the next, which contains a floating piston with a compressed nitrogen gas on the other side. This provides the spring force to ensure the road wheels stay in contact with the ground, but also dampens out vibrations. This system is much smaller, lighter, and easier to service than torsion bars, while lowering the height of the tank, lowering its
I mean, I get it. Like M1 Abrams, like 40-year-old, so that system was put in back then. So newer one is like basically height, the piston ones. So that makes sense. That feels like more. This is what I was talking like. It doesn't feel low tech, but because it kind of is. It's a 40-year-old tank. I'm constantly forgetting that this is a 40-year-old tank.
Profile and making it harder to hit. Not only that, but each individual suspension can be remotely adjusted by changing the gas pressure inside the cylinder, allowing the tank to take a crouch position if needed. Hydrogas suspensions were considered for the M1 during development, but it was a relatively new technology at the time, and so the torsion spring was chosen. The M1 Abrams has had incremental improvements added over the past 4 decades, with 3 primary variants: the M1, M1A1, and the M1A2, with even more specialized iterations in between, with updated sensors and controls to bring the tank into the 21st.
Oh, that's what it is. So M1A1. I constantly hear about M1A1. Isn't A2 better then? It's a newer one.
Like the Crows 2 on the M1A2 SEP. SEP standing for Systems Enhancement Package, which added additional thermal sights for the tank commander, an auxiliary power unit to run its electronics without running the fuel-hungry engine, and the Crows 2 controller, a remote control sight that allows the tank commander to operate the gun from the safety of the turret. We are currently on the M1A2 SEP V4 variant, and the Army is considering the future of the M1 program, whether that's the M1A2 SEP V5 or a completely new platform. But make no mistake, despite the M1 being one of the longest serving tanks in a modern military.
Isn't the Abrams X or something is the newer one? As I'm pretty sure somebody said that.
Over 4 decades old, it's still highly capable and will be a massive asset to the troops on the ground in Ukraine. The next episode of Real Engineering.
But would like 30 or so tank make a difference? I guess it depends how you use it. I don't know. But yeah, it feels like Ukraine and Russian war has like slowed down in a way rather than just like too aggressive one. I don't know, as far as I know. I don't know if something changed. But I feel like it will turn aggressive one day, and who knows, these tanks will be matter, I guess. I don't know. Or maybe just Russians suddenly pull out T-14s, a lot of them, and just surprise everybody. We already had that. We didn't tell anybody. It's under production. So there you go. Hundreds of T-14. That would be different. I don't know. Well, there you go. The insane engineering of the M1 Abrams. Right? This is M1 Abrams, which is like 2-3 versions of it. And the one I'm thinking of is like Abrams X, which is like, I'm guessing, the newer version, like T-14 type of way with the latest version of it. I don't know. Who knows? There's still video about task and purpose. I don't know if somebody made it or not. I can say it in recommended area. But I'm guessing that would have. I would be surprised if it has an autoloader, because that's the next generation thing. Who knows? Alright, well, if you like my reaction, don't forget to subscribe. Comment down if you want to do any of this specific reaction, and I'll see you next time.